right, welcome everybody. Thank you for being here. So today we're gonna have this workshop, and we're gonna introduce Kotlin multi-platform in an existing application. This is a workshop that will focus more on the actual process and all the stuff that you have to do in order to make the things work, so rather than what actually you can achieve with Kotlin multi-platform. That's because that part of having all the pieces working together is usually the most complicated one, and the one that requires a bit of things to make it work. I will be doing the thing. We'll be doing the thing step by step, but so you can follow it step by step, or you can just with your laptop, or you can just watch it. Feel free to. It's fine, both of the ways. Okay, before introducing a bit of the agenda, if you're gonna follow it step by step, you're gonna need, of course, Android Studio and Kotlin multi-platform plugin. But if you already updated to the latest version, so Koala feature drop, the latest feature drop, the Kotlin multi-platform plugin is not working for there's some issue on Android Studio. So if you have this version, and I have it, because of course I'm updating as soon as something gets out, we're gonna need to use this library wizard that is pretty much similar, but yeah, something to keep in mind. And also you're gonna need Xcode for the latest step. If you don't have it, I don't know if you're gonna be able to download it in a conference Wi-Fi probably, but I'm gonna do a quick introduction at the beginning, so maybe you still have time if you want to download it. And also you're gonna need a GitHub account because we're gonna use GitHub to publish the stuff for the thing. And if you want to check if your system have everything in place for KMP, there's a little tool called KDoctor that you can run it. And it's gonna point out if you're missing something. Yeah. So all the stuff that I'm gonna say are written in a step-by-step guide. So you can, if I'm going too fast or too slow, you can follow it step by step here. So you can grab the QR code or copy the link. Yeah. I'm gonna wait couple of seconds if you need. Everybody has it? Okay, so still thinking? Okay. Yeah, but if you haven't caught it, just tell me. I'm gonna put the link afterwards if you need. Okay, so agenda of today. So as I said, I'm gonna do just a quick intro about Kotlin multi-platform, just to be everything on the same place. Yeah, before moving on, just to know each other, how many of you already know what Kotlin multi-platform is? Okay, so I can go a bit quicker. How many of you already use it or tinker with it? Okay, nice. And I guess the majority of you are Android developers. Are there some people that are not Android developers? Okay, I can keep my jokes on Xcode. Nice. Yeah, in fact, I did this workshop once, and the majority of the room was iOS developers, so I had to cut all the jokes. But glad that I can have it back. Just kidding, of course. But yeah. Then, what I was saying, we're going to start from an existing Android and iOS application that lives in separate repository, and that is usually the most common scenario that we're gonna all have in our day-to-day job. There could be a chance that that you have a monorepo, but in the majority of the situation, there's separate repositories. And then we're gonna bring the business logic on Android, and we're gonna move it to a Kotlin multi-platform library, and then we're gonna use that on both on Android and iOS. Of course, we're gonna deploy the library on Android first because it's simpler and faster. Then we're gonna take a little break before diving into deploying the library on iOS. And we're gonna also see how to do it in a scalable way, so it's a thing that is working on a team and not just for a pet project. And then, if we still have time, I'm gonna quickly show how to improve the iOS API, so the entire team is gonna be happy. Okay, so I'm gonna go quick with a little introduction about KMP. So to just understand in a good way what Kotlin multi-platform is, we have to check the other classic cross-platform solution. And by that I mean only React Native and Flutter. The other are not worth mentioning because are not used so much. And yeah, those solutions requires an all-in approach. So you have to settle on a language, which will be Dart or JavaScript, depending on the tooling. And then you have to go all in. You have to share everything, UI included. You cannot just share a piece of it. I mean, you can, but it's not how the tool is supposed to be working. And because of that, there's of course, different platform has different pattern, different things. So you to find a unified way of doing things, you have to cut some edges. You need to do some assumptions, some things. So it's not everything is not completely smooth. Let's put it in this way. Of course, depends on the situation, but yeah, that's the thing. Kotlin multi-platform instead goes with an incremental approach, and so in this way you can decide what you want to share. So you can decide to share just a single function. You can decide to share a class. You can decide to go more crazier and share more stuff, like for example, the entire data layer, the entire business logic, or you can even share everything now with Compose multi-platform, even the UI. But the point is that you are the decider on what to share. If you're feeling that you want to share everything, you can share everything. If you're feeling that okay, a function is enough, you can share a function. And that's because Kotlin multi-platform can be saw as a library. So you can import that the single function or the entire thing that you're sharing as a library. You're existing a new project, and in this way, that's the powerful thing because you can decide the things that you want to do. Okay, the supported platform are different. So we have, of course, the JVM where Kotlin was born and where is at home, let's say. So the JVM and Android. Then there's Kotlin native that is responsible for running Kotlin on native platform where there's not a JVM. So basically the entire Apple family, and Linux and Windows. Then there's Kotlin JS for running Kotlin on the browser and on the server. And finally now, at the end now, there's also Kotlin WASP to run Kotlin on WebAssembly. It's still in alpha, but it's looking interesting, and it's going to be interesting in the future. But today, as I was saying, we are focusing on just on mobile, so only on Android and iOS. But you can extend the things on the other platform if you need. Okay, so how the things works. We mentioned before that Kotlin multi-platform works as a library, so we can import the Kotlin multi-platform code as a library in our existing project. And so what it means is that on Android, if we are in the same repository, we can import it as a Gradle module. So like every other Gradle module that you might have in your application. Because it's Gradle, so it's gonna work out of the box. Then instead, if you need to communicate with different repositories, you're gonna need to use a binary. So in this case, it's gonna be, on the case of Android, it's gonna be an AAR. If you are in the JVM, it's gonna be a jar. But yeah, that's the thing. On iOS instead, there's no difference between the same repository or different repository because Gradle and the iOS ecosystem are different things. So the only way is to distribute a binary, so the communication through a binary. And the binary in this case, in the Apple platform, is called Xcode Framework, and or XC Framework for brevity. And you can see that as the equivalent of that in the JVM world will be a fat jar, because in Xcode Framework you can put stuff. You can put both the architecture for the simulator and for the real device, and you can, and also, for example, if you still have an Intel device, an Intel Mac, you can also put the simulator architecture for Intel and whatever. So you can put different architecture in the same box. And also in the same box, you can put different family of Apple. So you can put your code for iOS, your code for tvOS, or your code for whatever other OS there's on Apple right now. Okay. So the structure that you usually see are mainly two. There's the structure with a single repo, with a mono repo, where there's the iOS app, Android app, and the Kotlin multi-platform code are in the same repository. And this, of course, is easier for new projects because you just you just create it from scratch, so you don't have the hassle of moving the repository in a single monorepo. Of course, it's going to work also for existing projects if you move everything inside the same repo, but it's more heavier and it's a more complicated step. But you can, of course. And the other situation is different repositories, each for every architecture. So a repository for Android, one for iOS, and one for the Kotlin multi-platform library that we're gonna have. And this is easier for existing projects because you just need to create the Kotlin multi-platform repository and then import it as a library in the existing project. Of course, it could work for new projects as well because why not? But yeah, it's gonna be easier for existing projects. Okay, enough talking. Let's go into actual work. And so, where are we gonna start? Is it fine? Should I move to maybe not dark mode? Is it more clear with light mode?
Better.
Better? Okay, nice. Okay, what you're gonna have, we're gonna start from existing apps. So you already have this link from the step-by-step guide that I shared before. If you don't have it, you can still go with this link. But yeah, it's the same link that is reported in the guide. So if you have it, no problem. If you don't have it, you can shout me and tell me, and I'm gonna share it again. But yeah, there's two folders. There's the end and the start. If you want to cheat, you can already go to the end and check it out. But inside the start, there are two repositories, one for Android and one for iOS. And those are the starting point that we're gonna work on it. So the app is pretty simple. It's just stupid news reader app that show a list of news. Again, in the workshop, we're not focusing on the actual feature or stuff, but rather on how the things works. So the thing is pretty simple. We have a nice database that, is it fine the font or should I make it bigger? A little bit bigger, okay. Okay, so the database of this app is a very nice hard-coded JSON for in the thing. We just wanted to keep things simple. And then there's a Okay, let me change it directly in the settings, otherwise. Okay. So yeah, there's this repository that is simulating a network request just to simulate the usual things that we have, and it's pretty simple. Just getting the JSON from the coded, it's decoding it and mapping it to domain models, and then the UI is a simple compose UI. We actually don't care about it. And then we have a view model that is just getting the stuff from the repository and just map it to UI state, just something similar, something classic. The iOS app is basically the same. Again, make it bigger. I lost the simulator. So a list of news, pretty boring, like the other one. Then again, let me make it bigger as well here. Okay, 24. So also here there's our nice hard-coded JSON. We have the repository that is doing the same. So simulating a network request, parsing the JSON. With Swift concurrency, so the equivalent of the suspending function that we have. And then, again, we have a view model as well, like on Android. In this case, it's doing the same thing, mapped to some UI state. In this case, we have, again, an async function here, like a suspending one. That's because we don't need the preview. That's because on Swift UI we can have a task modifier that can call not suspending function but async await functions. And whenever the UI goes away and it's destroyed, automatically the call will be cancelled, like in Android with the view model scope. But in this case, we are calling directly in this way. Of course, here doesn't make any sense because if the new screen goes away, the app goes away. But of course, in more complicated scenario, that's pretty handy and pretty useful. Okay, so basic stuff. So the plan is that we want to move the data and domain layer entirely to Kotlin multi-platform. So just have the presentation here and the presentation here in the native app, and everything else will be Kotlin multi-platform. So let's do that. So as I was saying before, I have the latest Android Studio, so the plugin doesn't work. But if you don't have the latest version, you can just go here, and I'm gonna show it nevertheless, just for future reference. But with the plugin installed, you can choose between creating an app, and the app creates the monorepo structure, or you can create a library, and the library creates the library that how we want. When you go forward, you can decide what to have. So calling, for example, like this, and let me copy that for afterwards. And here, when you go next, you can decide the name of the share module. You can decide to add some sample test, and here you're gonna have to decide the distribution way of that you want. In this case, for the library, we want an Xcode framework because what I said before, we need to distribute the thing to the clients. But if you're building an app that is in the same repository, you're going to use the regular framework, and in this way, Xcode is calling Gradle when you build the iOS app, and Gradle is figuring out, and Xcode is passing to Gradle the architecture information, and so it's able to build the framework with a specific architecture that you want. But if you're building a library, you don't know what architecture, if your consumer will use the debug mode, the release mode, whatever. So we have to provide an Xcode framework with everything inside it. Okay, I'm gonna close this because it won't work on my machine. So if you have the latest Android Studio, you can. We will use this this wizard that is. It's a nice wizard that is coming from the community, and it's used to generate libraries that is going to be used in other Kotlin multi-platform projects. But it's the quickest way that we can do to have it to use not on Kotlin multi-platform project, but actually on iOS and on Android and iOS. We will need to do some little edit, but that's what we have. It's better than do it manually. I hope that they're gonna fix on the next Android Studio version, or they're gonna release a new plugin version. Okay, but here I just put the name, the project ID. I selected Android iOS. You can select some libraries, and let me download it, and I'm gonna put that in my working directory here. Okay, let's put it here. Can I leave it like that? Okay, and we can open it with Android Studio. Okay, gonna trust it. Okay, this project usually have has already some stuff to publish the library on Maven Central, but we don't need that because we are just using it internally, and it's not a Kotlin multi-platform library. Okay, there's some issue with where I now with the latest Gradle, so you have to downgrade to 8.9 if you generate it with step by step with the wizard. And also here now while Gradle is syncing. Okay, thank you. No, I don't want the Android view. But yeah, here there's already some boilerplate here, and also with the Kotlin multi-platform mobile plugin, there's already boilerplate created. Here, as I was saying, specifically for Kotlin multi-platform library for Kotlin multi-platform use, so we don't need the conventional plugin here, and we don't need Intel machine. I don't have an Intel machine, so I'm gonna cancel that. Keep it if you have an Intel machine. And here, okay, and all right. We should have everything in place. We can delete that. And now we are ready to go forward. Okay, first thing first, we say that we want to move the data in the main layer, so we can just copy paste, pretty simple here. And of course we need some dependency because we don't, in the project we are using Kotlin Next serialization and also coroutines, and the wizard doesn't have, the project generated for the wizard doesn't have it. It will have it if I remember to tick those boxes, but I didn't, so let's put it things manually here, and then we also need the plugin here. Okay, and let's add it here as well. Plugins, Kotlin serialization. Thank you, Copilot. We can copy this here, and we can also add. We're gonna need the dependency here. Kotlin Next serialization.core. Of course, got Kotlin, JSON. Yes, JSON. And no, I don't want a cater now. Kotlin X. Core teams core. Okay, let's give it a sync. And now we just copy paste the things, but the package was different. So let's update the packages here. Same for here, and was not syncing. Okay, it's working. Okay, here we update the package as well. Here we have some red here, but we're gonna come back in a second. And then again, package updates here. And before it was, the class was internal because that was inside business logic inside the project. But right now, this repository will be the entry point of the entire thing. So we need to change the visibility to public, and same things for the news object. And okay, and we have the main structure here. So now let's go back to this red, and why the things is red. Well, in this case, we are using Java libraries here. I mean, not Java libraries, yeah, but code that is coming from the JVM specifically. And we are trying to use that inside the common main source set. And we can do that because the common main is a common source set. And inside this, we cannot use anything that is platform specific. So we cannot reference any Android, any iOS, any whatever other platform you're using. So in this source set, there must be only pure Kotlin code. So of course there's a way to handle that because with Kotlin multi-platform there is the expect action mechanism, which is basically let you write in the common source set an expected declaration, so that you're expecting something. And then in the platform specific source set, you're gonna write the actual implementation of it, and the compiler will connect everything. So we are making sure that we are providing an implementation for every platform that we are supporting. Here we can see a little warning, and the little warning is because no, I don't want a VPN now. The little warning is because it's expect actual for the expect actual mechanism. It's stable for function. For interfaces, object, annotation, enum, and type alias, it's in beta. They're not gonna remove that, but they say that the design of those things it's a bit complicated, and they are thinking maybe to change something, but they still don't know about it. So they have it in beta to have the chance to maybe do some breaking changes. But it's not that they're gonna delete the thing, so don't worry, you can use it. And if you hate warnings, like I do, you can just make it shut up with this with a compiler option, so you don't gonna have the warning. Okay, at this point we need to create the actual definition in the source set. So we're gonna go with some option enter driven development, because there's a IDE integration that is going to pop up a little menu that you can decide where you want the actual implementation, and it's pretty helpful. Otherwise, you have to write it manually, which is not always the best thing. So in this case, we want it on Android, and here you can even decide in which specific source set you want the thing. So you can even go more granular and have a definition only for the simulator, only for the real device, or everything iOS, everything Apple, everything Kotlin native. In this case, we want just for iOS, and so we can we can hit the button. And in this case, as you can see, there's some more generated stuff. So let me copy this for laziness. And here there's the Android source set with the generated actual implementation, and same there's here for iOS. And we have, of course, to fill the to-dos. On Android, we can just copy paste the things that we were using before, because we are inside the Android source set, so we can reference anything that is available on Android. We can even import every library every Android library that you want. You can import like that. Then we have to do the same for iOS. And for iOS, we again here in the source set we can use any iOS specific APIs. In this case, those APIs are in Kotlin, but it's calling stuff that are in the device that you're gonna use. And here, the Kotlin native compiler is automatically do the binding for us. So it's generating Kotlin code for functions that are instead coming from the iOS platform. And yeah, those are usually the same names. So if you just Google this, you're gonna find the documentation for iOS, but you're calling Kotlin, which is pretty handy and pretty nice. Okay, at this point we have everything ready. Of course, for doing the things here, just for string formatting, it was a perfect example for showing the expected actual. But yeah, don't do it manually. There's a Kotlin Kotlin library from JetBrains for doing for handling datetime and those formatting that does these things underneath. But yeah, it was a perfect example for demonstration purposes. Okay, so at this point we have all the code. We have to start using this thing in our project. So we need to publish it somewhere, and to make it easier, we're gonna start to publish locally in our Maven local. And to do that, we can use the Maven Publish plugin. Here in this case, there's a reference inside the Gradle, so you can use it this way, or you can type it. You can type it like this. Is the same thing. So to publish on Maven local, we need set it up. So we need the plugin. We need to define the group that was already done by the wizard. Probably the Kotlin multi-platform mobile plugin is not generating it, but I don't remember. So make sure that you have it. And let's do with a more initial version of 0.0.1. And also another thing that you have to do, if you don't have it, is defining which variants you want to publish for Android. In this case, the library is publishing the library in the wizard is only publishing the release version. I usually like to publish everything, just to be sure that it's covering both scenarios. So you can write publish all library variants, and it's gonna publish the debug and release version of the Android library, and Gradle will connect your Android project. But yeah, it's up to you what to publish. Okay, in this case we are ready. We can give it a sync, and we can to publish on Maven local. There's the publish to Maven local task that we can call it. Usually it's not taking so long. It's pretty fast, and it publishes our library on our Maven local repository that we have in our machine. And at this point, we are ready to actually use the library in our Android project. Okay, so let's do it. Let me first delete the code that we copied over. And let's first do some Gradle setup. So we publish the thing on Maven local, so we have to tag to Gradle to go grab it on Maven local. Yeah, at this point we can just reference our library. No, I don't wanna. I forgot how we call it. Oh yeah, okay. But yeah, you just need to have the group. To have the group, yeah, and the module name and define it like that. I will not put it into version catalog now, just to keep things easier. But after a sync, if I haven't messed things up, the things should work. So to make it work, of course, we need to change the package name because we changed that before. And yeah, we changed it and it's resolved. And I'm not lying. And the thing is, if you navigate through the project view, you can see that the thing is coming from the library, from the bug version of the AAR that we just published on our Maven local. Okay, let's update the other stuff. I should have something here, I guess. Okay, and let's run it to make it sure that that things are working. Okay, it's working. Nice. Okay, so we have our business logic now with Kotlin multi-platform. We have it published locally. Of course, we cannot ship our computer to our teammates, so we need to actually publish this thing somewhere. And we are talking about Maven, so we can publish this thing in a Maven repository that you're gonna have. So if you already have your company a Maven repository set it up for other reasons, you can use that. Otherwise, you have to find a Maven repository. If you don't, there's different thing that you can have it. Maybe you can self-host it, something or whatever. But if you don't want all those troubles, an easy choice is GitHub Packages that has support for Maven repository, so you can have a Maven repository in your GitHub repository, which is pretty handy. The only thing, and it's working quite nice. We use it to work. It's working. The only gotcha is that the company it's not public, so probably it's not a big deal. But yeah, to proceed with the code lab and to publish the thing, you're gonna need to, if you don't already have it, you need to create a personal access token with that scopes. I mentioned the scope here as well in the step-by-step guide, so you can find the scope there if you don't have a personal access token. Okay, so we say that we can use GitHub, and of course to use it we need to publish this repository that we just created to GitHub. So let's do it, and let's have it here. Let me call it like that and put it on my account. Okay, public. Okay, I'm gonna need that, and then we need to initialize Git, of course, here because I didn't have it before. Let's put it back every time. Okay. And let's put a remote. Okay. Let me check that I have actually pushed the thing. Okay, push it. Okay, and at this point we can publish our thing, but of course first we need to tell to the Gradle Maven publish where to publish the thing. So to do that, we can define a publishing block that is coming from the Maven publish plugin, and in here we have to define the repositories. In this case, we have a Maven repository with a name that you can put whatever you prefer. You have to put the URL, and the URL is your GitHub repository with maven.package appended in the front. And then you're gonna need the credential. Username will be your username of Git. The password is the personal access token that you created. You can put that in different places. I have it on my environment variables, and then I'm loading it here. But you can, for example, have it on local properties, and then read the local properties, or probably not hard-coded here. But yeah, there's different ways. The one that better suits you, you can choose that. In the step-by-step guide, I mentioned the different ways, so you can choose the one that you prefer. And at this point, we have to publish our stuff. So let's publish it. It's a long command. I'm gonna run it, and then I'm gonna explain what the command does. So there are three different commands. The one is publish Android release publication to GitHub package repository, and this is publishing the release version of the Android library. There's the one that published the debug version of it. It's exactly the same one. And then we have another one that is publish Kotlin multi-platform publication to GitHub package repository. And this one is publishing the Gradle metadata for the Kotlin multi-platform library. And Gradle metadata for such libraries are some information that will tell Gradle which platform you're calling that library. If you're not publishing this publication, then here in your library you need to specify -Android, or if you are in the JVM you need to specify -JVM, which is not good looking, I would say. So I suggest you to publish also those things. There's also just a publish task that it's publishing everything. I'm not using that because if you call this, it will also publish the iOS stuff but not the iOS stuff for using in an iOS app, but the iOS stuff to use in another Kotlin multi-platform library. So in this case, we don't need that, and so we don't want to just consume space on our GitHub account for something that we don't need. Okay, so at this point we publish the thing. Let me check on GitHub if on GitHub we're gonna refresh it. Here we're gonna have the package that we just published. So if we check it, we have the version, etc., and with all our packages. And so if we go back to our Android app, now we need to change things. I mean, and by things I mean the repository settings in the settings.gradle, because now we don't want Maven local because we publish the thing for everybody in the team. And so we need to tell Gradle where to pick the stuff. And in this case, it will be the exact same snippet of code that we pasted here, because the references are the same. But in this case, we're not publishing anything, so we just need the reference for the library. So now I'm gonna sync it, and if I haven't messed up something in the publishing, things should be working as expected. I guess. Yeah, if you go in the download info here, we can see that we made some requests to maven.package, maven.package.github with a 0.0.1, and it was successful. So if we run it again, it's gonna just to make sure, yeah, it's running. Nice. So at this point, you have your Android code to a Kotlin multi-platform library that is published on GitHub packages, and so now you and your team can start using it in your Android application. And at this point, we're done with Android. Now it's the turn for iOS, but maybe we can take 5 minutes or something as a break, and then if you want, and then start later. If you want, otherwise I can continue. But yeah, let me know. Yeah, and if you have any questions, feel free to stop by and say.
I have a question.
Yeah.
Is there anything with the Maven repository of GitHub or any other that is special or need to be changed that it can handle those other artifacts?
You mean if you change from GitHub package to some other stuff?
No, I mean normally Maven Central or something like that was used to store jar files and AMRs, and now it takes all the other formats. Is there any problem with that?
No. I mean, there's no problem with Maven Central. In this case, GitHub packages is maybe more suitable for internal stuff. So that's why I'm using it. I was using it also because it's simpler to set up in this situation. But of course, if you have an open source library, Maven Central is still the place to be. But yeah, for internal use.
The Apple frameworks.
I know. Yeah.
Formats, that's no problem.
No. The Apple framework won't be stored in Maven packages. In that Maven.
Maven Central doesn't say, oh,
No.
Don't give us the Android iOS code. We don't want that. They are not saying that.
No, for the Xcode framework, you cannot put that there because it doesn't make any sense. I don't think that it's supported. But if you publish the Kotlin multi-platform library for iOS, and so not the final artifact, the Xcode framework that we're going to see in a second, then it's fine on Maven Central. But in that case, it's for usage in other libraries. So if you go, for example, on here, yes. So for example, for my library, if you go there's different artifacts. But yeah, this is a specific library. So there's artifacts for iOS, but here those are, since it's a Kotlin multi-platform library, there's the jar and then there's the klib for Kotlin multi-platform. But yeah, this is supposed to be for to use this in another Kotlin multi-platform library. So it's a different thing. Okay. So shall we wait 5 minutes and then start again, or if you have any questions? With that, we can start again. Yeah. Okay. So now now we need to go to the more complex part. So as I was saying before, we need to publish our library with on iOS, and the format is with the Xcode framework. But of course, we just don't want to put an Xcode framework out in the air. We want, of course, to use dependency manager to have it in a proper way. And so let's do a very quick dive into iOS dependency management. So the first tooling that came out to do the thing was CocoaPods, which is basically a centralized dependency management for iOS based on Ruby. So every time I used that, I had issue with Ruby installation on my machine because it tends to break for reason. But yeah, it was the first. Dependency manager. It works great, but it had some issue because of being centralized and Ruby. So afterwards, there was another solution to fix CocoaPods, and that was Carthage, and they tried to make decentralized, which was kind of okay-ish, but it was very complicated to set it up. It's not an easy tool. Let's put it this way. And then at the end, some years ago, Apple came with their own solution, that is the Swift Package Manager. And right now, basically, the industry is moving towards only the Swift Package Manager. Even CocoaPods now they recently announced that they are more in a maintenance mode because the industry is moving with the solution provided by Apple. And it's nothing fancy, the Swift Package Manager, because underneath it's Git, so it's basically fully based on Git. And you can configure it with a package.swift file, which, to make it easy, it's kind of the equivalent of a POM file with the information that the library needs. And it uses semantic versioning with the Git tags. So if you want to publish a new version, you have to put a new Git tag with a specific strict versioning. So you have to use the 3 number of the version. If you put only 2 numbers, it's not gonna work. It's gonna fail, which is something that needs to be reminded. And the interesting thing is that the Swift package manager, in a Swift package, we can put either code. So, for example, for an open source library, we can just have the code, and then Xcode will figure out how to build everything. But we can also put binaries, and this is handy for example, for closed source libraries, or in this case, because we have an Xcode framework that is generated from Kotlin multi-platform, and we can put the binary inside it. And since we are talking about Git, the thing can be local or can be remote, because it's Git, so we can publish the Git repository that it's underneath. So let's go back to coding and go back in our repository, in our Kotlin multi-platform library, and now we need to do some setup because we want to publish in an Xcode framework. And so to do so, we need to define an Xcode framework object here in the build.keynote file, and we can also give it a name. Let me copy the correct name, just not a typo. And this is basically telling Gradle to create this Xcode framework. But and as I was saying before, the Xcode framework can contain different framework of specific architecture. So in this case, we have to tell Gradle to please put the specific architecture. In this case, we have 2 here, ARM64 for the real device and ARM64 for the simulator. And we have to add both of them inside our box of Xcode framework. And we also need to change the base name here. And remember to do so because the base name is what is gonna show on Xcode and what will be imported on Xcode. And if you leave shared, it's not gonna look great on having import shared in the iOS app. So yeah, change it to not make your iOS colleague freak out. Maybe you can call it something kit because they like appending Apple-like kit at the end, but yeah, feel free to call it whatever you want. Okay, at this point, we just need a sync. And after syncing it, now new Gradle task will appear. And there's gonna be, this task that is assemble newsreader, assemble the name of your thing, Xcode framework. And a debug version, a release version, and there's also one for building both that I cannot see there, but probably the search. But yeah, you can build both at the same time. Now let's only build the release just to make things faster. And when you run this thing, it's gonna take a bit. I mean, not so long, but not so long like 2 years ago. Now it's better. But yeah, and so here it's gonna pack the thing. It's gonna pack the code into an Xcode framework, and it's gonna put that framework here in the build folder of your library. And here, as you can see, you're gonna have a release folder. If you build a debug version, there's gonna be a debug folder here, and then you have the framework here. And that's the thing that we need to ship to, we need to import to our library. So we could manually import it, but yeah, it's not the same thing to do without a dependency manager. So let's actually create our Swift package, and we can do it since it's Git, we need to create a new Git repository. So let me, of course, where was workshop working there? Framework? Yes. And let's call it newsreader KMP. And here we just need to put, first of all, the framework, so we can just drag and drop it here inside it, and then we need to write a package.swift file because we need to define how Xcode will consume this. So we're gonna need to tell Xcode how to consume this. So just copy paste it. Don't forget to put this comment. Once I forgot, and I had to debug for, I don't know, 30 minutes. I wasted 30 minutes of my life to find out how it's not working. And it was not working because I forgot this. So keep in mind and put it. But yeah, in here we are just defining, like in the POM on the JVM, we are defining the library. So in this case, we can put a name. We can put the platform that are supported and the minimum version. We can put here. We can put .macOS or whatever OS we are supporting. Then we are defining a product, and basically the product will be the thing that you're gonna import on Xcode at the end. So this will be the name of it, and the product will have a specific target, and the target here can be of different type. Can be a source code target. So if you have an open source library with a source code, you can define the source code here, or in this case, a binary target. And in this case, the binary target is pointing to a specific path, and the specific path is will be the thing that we have here in our file. And that's it. Xcode will parse this package.swift file and will understand that it needs to import this. So Now we need to publish our framework. So let's, okay, I forgot to update my settings. Okay. And let's, okay, so now we can add everything. We can have a first commit. And then we need to tag the commit to actually do the thing, to actually publish the thing. And now we can use that in our Xcode project. So let's go on Xcode. Let me first of all delete the code that we don't need anymore, and we need to import the library. So to do so, we have to go on our project, select the project here, package dependency, and here we can add a new package. Here is gonna scan. I already have it. Here you can add the package that you want. In this case, we are using a local package, so we can use add local. Find where we put the thing here, and if I haven't messed up, okay, I didn't. Here, Xcode found the product, and we can add this to our target, which is now the main application target, not the test. And if we hit add, here we have our project, our framework added here. So if we go in the code here, we can we have the import, and we can import the stuff. So let me import it in all the other places here, I guess. And if I haven't messed it up, it should be working. Ah, yeah. I cannot. Okay, I messed up the I messed up. I have a typo somewhere. No, I didn't want to open with Xcode. Okay, this is correct. This is correct. Yes. Can't be. Okay, now it's going to be interesting to find out where I mess up. Let me import it again. You already have my token done. Nice, it crashed. Always lovely. Okay. Probably it's a cache issue, because I remember doing that typo on a rehearsal back a couple of weeks ago, and probably kept the cache. Yeah, the module here is correctly imported, so. Yeah, okay, that was a cache issue. Thank you for being so verbose in the error. Should be working. Yes, it's working. Nice. All right. Okay, so it's working, and basically I haven't changed anything. And in particular, as you can see here, this is apparently, again, a Swift async await function. It is, but there's some gotchas. So basically, the news repository here, fetch news, is a suspending function, if you remember, in the repository. And in this case, it seems that it's automatically ported to a async await function. Technically, it's not, because on here, it's the compiler of Kotlin native is automatically converting suspending function to function with a callback. And then Swift, there is a recent version of Swift, they converting specific function with callbacks to async await functions. So that's why it's coming up with a async await function here, and it's apparently it's working. But this doesn't support cancellation. So this will run forever. It won't be canceled because there's no cancellation in that out of the box. We're gonna see it in a second how to fix that. But yeah, take in mind that that for now. All right. At this point, of course, we have everything locally. So we, since it's a Git repository, we can just push it upstream. So let's do it. And then copy this. Let me do it here. You can create a new repository. You can add, and from the one that you just created, you can, what's new now? Okay. Is the one, okay. You can just push the thing here, and also the tags, because it's a Git repository under the hood. And in this way, you publish the thing. So if you go if you go now on Xcode, you can just directly import that library. So we can delete that, and if you search here we can Xcode automatically pass the package, went into the URL, clone the thing, and then it's telling which version we're going to use. We can specify here the tag that is published, or even we can say bring a commit or bring a specific branch. So if we add the add package here, it's gonna clone the repository, pick the correct tag, and pick the correct thing. So in this case here we are using the thing, and if you're gonna run it, it's gonna run. This seems easy and fast to do it, but don't do it. Don't do it because, as I was telling you, right now Xcode is cloning the entire repository where you push the thing, and this is okay if you are right now with just one framework. But if you're gonna scale the thing and use it on your team, you're gonna have a lot of framework published because you're doing day-to-day development and stuff. And when the repository is gonna reach 5 gigabytes, which seems big, but I mean, it's not. You're publishing frameworks. You're gonna publish probably the debug version, so with symbols and stuff is gonna be a little bit bigger. So when the repo will reach 5 gigabytes, Xcode will start to struggle and crash and stuff, because it's when you're asking for a specific Git package, Swift package, Xcode is downloading the entire repository first, just to be sure to have everything, and then it's gonna have it. So if if you surpass 5 gigabytes or around that area, it's gonna take a while and it's gonna struggle because it has to handle a lot of space and it can't, apparently. So, yeah. So, how to do it? Well, let's go back. And there's actually a way of doing that because likely Swift package allows you to put different target, as we see before. Before we put a binary target with a local path here in the package Swift. We just had a local path, but you can zip the framework and put the zipped version somewhere in the internet, and Swift package support that. So you can zip it, have a checksum just for not have man in the middle stuff, and put it somewhere in the internet, and then use it. In this way, Xcode won't download everything before figuring out the things, but will just download the zip that you have it. It will unzip it and will figure out the things. We'll check the checksum, and then if everything is in place, it will use it. So the point here is that at this point you have to figure out where to store the zip file, and again, where to store the zip file, it depends. You can store it wherever you want. If you already have an infrastructure at work where you can put stuff, you can use it. Or if you don't have something specific, there's again tooling for that. So for example, there's a tooling from TouchLab that is called KMMBridge that is helping us to do this stuff because it's automating all the processes to publish the thing, and it lets you publish the zip file in a different backends or different storage providers. You can have it on GitHub releases, for example. You can have it on GitHub packages using Maven. Basically, that's a trick, and it's basically storing a zip file inside a Maven repository, which it's a bit sideline for Maven, but you can do it. Or you can put it in other Maven repository, again, in this way, or in Amazon S3, or whatever other storage that you have. And it's pretty handy. I like it a lot, we're using a lot, and it's also pretty easy to set it up. So we still have time, so I'm gonna show you how you can set it up very quickly. Basically, it's just a Gradle task that is automating a bunch of things. Sorry, a Gradle plugin, not a Gradle task. So you can import that. Libs.plugins.kmmBridge. And I have the same here. And in this case, KMMBridge will automatically set it up the Xcode framework here, so you don't need it to do it manually. And we need, of course, some manual setup, some manual configuration here. So we can just tell, first of all, to publish our Swift package manager things on GitHub releases, and to use SPM for it. The KMMBridge is gonna help also on streamlining the Android publication because it lets you define this thing. And basically, under the need is setting up this publishing thing, and is automatically gathering the information from the CI. So if you run it, if you have GitHub Action and you want to publish also the version for Android on GitHub Action, you can just not have this, and just set it up this, and it will automatically on the CI do all the setup for the Android version. And we don't need the name publish, but yeah, let's leave it. Okay. Then the other change that you have to do is disable for now configuration cache, because it's not, you may have seen here before, apparently it's not yet compatible, the Maven publish steps. So let's disable it. And another thing that we have to change is how we set the library version here. With KMembridge, KMembridge is automatically reading the version from somewhere. It comes handy to have it in Gradle properties, but you can put it somewhere else. But yeah, you can put it on Gradle properties and then read from here. So how the things works here is going to work with a GitHub action in combination with a GitHub action. Because it will be using GitHub releases, of course. But you can also run it KMembridge locally to generate the zip file. It's gonna generate the things for you if you want. But if you're publishing on GitHub Actions, let me copy the GitHub action. Probably we won't have time to wait until the GitHub action finish. Maybe. But maybe not. No, it's gonna take more than 10 minutes, and in 10 minutes the slot is over. But let me quickly put it here just to show it to you. So GitHub, of course, as misspelled. And workflows. Yeah. So I will. Yeah, there's a bunch of stuff that we don't care right now, but yeah, basically it's the action is gonna. It will read the version of the library from the Gradle properties, and this is necessary for afterwards setting up the Swift.package file. And yeah, there's a bunch of Gradle setup. And the main point, the main core of the thing is here. So here is doing the exact same thing that we did manually before. So they publish the release version, the debug version, and the multi-platform publication. And then is running KMembridge publish, which this task will build the Xcode framework for us, will create a zip file, we create a package.swift file automatically, and then it will put that in our repo. It will comment it, but it won't push it on the main branch because it's gonna create a tag with that comment. And so in this way, it's not gonna pollute our repository with a package.swift file, which will be strange to have it in the Kotlin multi-platform repository. But it will create the touch tag with the thing. So when you import the thing on Xcode, it will work, but it won't pollute the local. It won't pollute with just a random package.swift file. We won't have time to run it, but we can always look at the end here to show it like it's gonna work. So at the end, you're gonna have a new release. In the new release, there's gonna be the famous zip file here. For convenience, is referencing also the Android stuff that has been published. And if you see here the commit of this tag, if you go in the commit will have it's a detached commit because it only has a tag. And in here, there's going to be the famous package.swift file with the URL of the things where you publish the stuff and the checksum, and it's setting the things up. Of course, you're free to handle it manually, and of course, this is a way. It's not the only way. You can generate the zip file manually, publish somewhere, and then have a repository with just a package.swift file in there, and use that as an entry point. But yeah, it depends. This is a convenient and quick way to use the thing. Okay, we just have 5 minutes. So, am I correct? Okay. So let me quickly go to the iOS API improvements. I won't go deep into that, but I'll just give you the pointers about it. So basically, the issue is that right now the framework that is generated is from the Kotlin code is an Objective-C framework. And then it's used on iOS in Swift because Swift is interoperable with Objective-C, like Kotlin with Java. And that has been done because when they started prototyping Kotlin native and Kotlin multi-platform, there wasn't a BI stability on Swift. So yeah. Doing Objective-C was easier back then. Now, of course, there's the limitation ramping up, and there's some gotchas about it. For example, there's no namespaces, so if you define the same class in different, the same class name in different package, it works on Kotlin. It doesn't work on Objective-C because it doesn't have namespace. So the compiler will add an underscore in front of it. There's no default parameters, so on iOS you will have to manually define even if you have default on Kotlin. The enums are not Swift friendly because on Swift enums can contain values, which is the equivalent of seal class on Kotlin. But this is a Swift concept. There's not on Objective-C, so there's nothing in all the flow. Again, seal class are just converted as a simple classes again, so that's another gotcha. The equivalent will be enum with values, but you don't have it. The coroutines, as we've seen before, doesn't have cancellation in that. And for flows, you have to manually write the collector, so it's a bit of gotchas. It seems awful from this slide, but it's not, because there are ways of improving this in a good way. Well, of course, they're gonna be the official way because JetBrains is working on a Swift export tooling. It's still in the early stage of development. There's a prototype in the Kotlin repository with some documentation, so it's interesting. You can have a look at it if you're interested, but don't use it in production for now. But of course, the community came up with a solution. So for handling coroutines, you can use KMP native coroutines, which is a nice library that generates the boilerplate that is necessary for handling cancellation and collection of flows. And then you can have specific iOS libraries to connect coroutines with Swift concurrency, with Combine, and with Rx Swift, if you're still with Rx. Hopefully you're not, but there's still the possibility. Or another way is, again from TouchLab, is using Sky. That is a Swift API-friendly generator for Kotlin multi-platform. And this tool basically will fix everything in the slides that we have seen, except for the namespace, because it's unfixable. But basically, it's pretty handy, because you can just import the Gradle plugin for it, and then it will automatically generate the code for you, and will automatically generate the Swift code. It will link it back to to the framework that is generated from Kotlin, so you don't have to actually do nothing. And you're gonna have all these goodies for free, actually. So if you're starting a Kotlin multi-platform library right now, to use it, just add Sky as the first thing, and you're gonna profit for that. Okay, so to wrap things up, I spoiled the entire slide. But yeah, the powerful thing, again, the powerful thing of Kotlin multi-platform that I like is that you can choose what to share. So you can just share a little function, and also you can share a small thing just to prove your idea, to prove that it works for your team and for your staff. Also because you need to set up a different stuff, like we've seen before, the framework, the publication, whatever, how to use it. So I suggest you to do this process with little effort. So you don't write the entire network layer first and then figure out how to use it, because it's not going to work. I mean, it could work, but in the case it won't, it's going to be a little bit of headache. But yeah, and once you found your perfect approach and infrastructure and situation and how works your team, then you can go bigger and you can scale up things. So before actually closing it, some reading. So what I show you today is how to publish the binaries, and this is the easiest way to start with. But now there's more thinking if it's actually the correct way, or if you maybe want to share the source code instead and not the binaries, and then have it locally. So it's an evolving space. So there's some discussion, some thinking if it's the correct way or there's more efficient way. So this is a good read to get into this idea. But for now, what I suggest, if you're starting now and you want to get it out of the door, start with publishing binary, because it's at the beginning it's easier, and then figure out how it works your company. If you want to scale up to do every feature with KMP, then maybe every binary could be a bit cumbersome. Instead, if you have, I don't know, some utilities like the data layer, like whatever things written with KMP, that maybe have a binary publish, it's fine, because you're not gonna change the data layer every day for a new feature. So in this way, you're fine. But yeah, there's no a right way, like everything. It depends. So yeah, it's also a thing to find the right way for doing the thing. Okay, enough babbling. Those are useful links that you also have in the step by step. Thank you very much. There was a lot of content to put it in it. I hope it was helpful. If you want to give some feedback about the workshop so I can improve it in the future, feel free to do so. I will be helpful for that. And yeah, thank you very much. If you have any question, I'm here, or you can find me around, and we're happy to chat about it. Yeah, thank you.